Hi everyone, I hope you can hear me and see my slides. Hi everyone, my name is Sam. I'm from OWASP London. I'm an OWASP London chapter leader and also OWASP Nettacker project co-leader. A little bit more about me. I'm also chair of the OWASP chapter committee, where we help various OWASP chapters all around the world to be successful, healthy, run lots of events, make sure that chapters have all the resources. I come from a software development background. I'm an ex-developer myself. I'm an application security consultant. I work in financial services in the City of London, consult organizations such as banks, investment funds, pension funds, and e-commerce organizations, so mainly in financial services. So by all means, I am a defender. I'm not an attacker. I'm not a pen tester. I'm not a red teamer. I'm a blue teamer. I'm a defender. So why am I presenting a talk about a tool which consists of two words, network and attacker, if I'm an application guy and I'm a defender? My story with Nethacker started a few years ago when I saw OWASP Nettacker appearing on the list of the OWASP projects. I saw it being showcased somewhere on the list of new projects on the OWASP webpage. I ran it. I saw a whole bunch of options on the screen. I didn't understand anything what it was doing, so I just closed it and forgot everything about it. But few months later, I received an email from the project leaders of OWASP Nettacker, and they said, "Dear OWASP London chapter leaders, can you please go to BlackHat Europe exhibition in London, which happens every December, and present OWASP Nettacker instead of us because we're having a bit of a problem getting to London in time." So we said, fine, yeah, we will be happy to help fellow OWASP project leaders. So myself and OWASP London chapter co-leader, Dr. Greg Frakos, we learned about this project overnight. We got on a Zoom session with project leaders, and from zero to hero, we knew absolutely nothing about the project. And in several hours, we found out quite a lot about it, and we absolutely loved it. So next morning, we turned up at the massive exhibition hall at BlackHat Europe, and we started presenting this tool. And then this happened. We had huge crowds of security consultants, penetration testers, even some CISOs and senior managers turning up at our booth, all watching the demo of Nethacker. Everybody loved the tool. I said, what is this? A free open source tool for network vulnerability scanning and Recon. We definitely need to check it out what it is. And it is from OWASP. We said, okay, looks like people are interested. Let's do it again. And in 2019, we repeated this. So we had even bigger crowd of people gathering around our stand. And we talked about Nethacker a lot, and even more people liked it. So what is OWASP Nettacker and why everyone is looking at it at exhibitions? And most people probably watching this presentation have no idea what it is. So OWASP Nettacker, first of all, is an open source software tool, which assists with penetration testing by automating information gathering and vulnerability scanning tasks. It's written in Python, and because it is in Python, it can be run on Windows, Linux, Mac OS, basically almost anything which can run Python. As a demo, I ran it on Raspberry Pi, and it worked absolutely fine there, which is fantastic. So that's one of the major advantages of this tool, is that because it's written in Python, it's very portable. So another important thing to mention about Nethacker is that it's one of the projects which was chosen by Google Summer of Code program. So if you don't know what it is, Google Summer of Code is an initiative by Google, which is run every year. And essentially, it is a paid internship by Google, which invites students from all over the world. The main requirement is to be an active student at the university. And this internship is about students contributing to open source projects. And there are various open source organizations participating in this initiative. OWASP participates in it as well every year. And we were quite lucky that we had several students who participated and improved Nethacker. So basically you can say that it is a tool which is written by students, which is absolutely great. So if you are a student yourself, or if you know a student, I invite you definitely to check out Google Summer of Code. They usually start accepting applications from students at around March time. And then the selection happens. And what happens is that students work on open source projects throughout the summer break. And because it's a paid internship, they actually get paid by Google. And of course, they advance open source software, and in our case, of course, OWASP projects. Quite a lot of OWASP projects benefited from having students working on the projects. For example, OWASP JuShop, OWASP Zap are a couple of quite big OWASP projects that I can mention, which benefited from this as well. But of course, OWASP Nettacker as well. So what is OWASP Nettacker? You can think of a Nettacker as a kind of a Swiss Army knife tool, which is a tool consisting of many tools, just like a Swiss Army knife. And just like with Swiss Army knife, there are tools which are not necessarily compatible with each other, but can they all be used together, right? Can you pull several blades out of Swiss Army knife and use them to achieve a specific task? So with OWASP Nettacker, you can, because just like a Swiss Army knife, it's a collection of tools which are architected in a modular structure. The modules themselves, they're quite easy to create, especially in the latest version of Nettacker, version 003. I'm going to talk about this a little bit later. Because the tool is using Python multi-threading model, it is quite fast because you can control how many threads you want to perform your scanning and how many threads you want to run in parallel, how many threads you want to run on a host. So you can actually control the speed of the tool. And if you have a machine with lots of memory and lots of resources, you can actually perform scans really, really quickly. Another advantage is that it has customizable profiles, which are bundles of modules which are focused on specific tasks. I will talk about this later, but it's a very useful feature because you can basically name a bundle of modules as a profile, and then basically pull them out of your Swiss Army knife altogether to achieve a particular task. And of course, the greatest advantage of Nettacker that it is automatable. You can automate it and you can run it from command line. You can run it as a cron job. You can run it in your build pipelines. It's absolutely fantastic because it is very easy and simple to automate. A few caveats about Nettacker. It is not an officially released tool yet. It is not even in beta. It is still in development and research phase. The current versions are 002 and 003. So 003 is the latest and greatest version, which has a lot of new features. However, it is still not quite stable. We're still working on it. And we hope to bring it to a sort of enterprise-ready state very, very soon, hopefully with the next version. The current stable version is 002, so I'm going to be doing a demo on it. Just like any open source software, we're always looking for more contributors. And if you like open source, if you know how to program in Python, you're more than welcome to contribute into Nettacker. I will tell you how you can do it at the end of the presentation. But what are the advantages of the tool? So Nettacker already has a command line interface, so you can use it from command line. It has a web UI, so you can use it from your web browser. It has an API, which means you can automate its usage externally using an API. It has a report generator, and it has something called Maltego transforms. So people who use Kali Linux, for example, probably are familiar with the investigative tool called Maltego, and it has over 70 modules. Where do you find Nettacker? Nettacker can be found on the main OWASP website. This is the URL, www.project-nettacker, or you could just Google OWASP Nettacker, and you will find its page. The actual documentation is located on GitHub. That's where the source code of the application also is located. And unlike some other open source projects which don't use the wiki feature in GitHub, we actually do. So if you click on the wiki button in GitHub, you will access the documentation of the tool. And this is where you will find installation instructions as well as several usage examples and full documentation on all the features of Nethacker. So what is the difference? A lot of people ask this question and saying, why do I need Nethacker when I already have tools such as Burp Suite or OWASP Zap? This is a slide which will briefly tell you the difference between these tools. So tools such as Burp Suite or OWASP Zap, for example, also known as dynamic application security testing tools. What these tools usually do, they scan one website for many web application vulnerabilities. And that's whatever the scanner is able to find. Essentially, OWASP Zap or Burp Suite, they crawl one website to discover all URLs, all forms, all parameters, all buttons, all API endpoints, and then they try to discover any vulnerabilities. So OWASP Nettacker works slightly differently. So it scans one or many websites, and that can be not just, when I say many, it could be hundreds or thousands, and that's IP addresses, networks, or subdomains. And what it scans it scans for open ports or one or more specific vulnerabilities listed by the user. So basically these vulnerabilities, you can bundle them in modules. So that's the main difference. So it's basically a mass scanner. It can scan the whole network. That's why it's called network attacker or Nethacker. So how do you install it? I'm not gonna demo the installation because it will take a bit of time, but it's relatively simple because it's a tool written in Python and you can read the installation instructions on GitHub. Today, for the demonstration purposes, I will use version 002 because the version 003 still has a couple of issues, but it has some great features, and I'll show you these features at the end of my presentation. A quick reminder, before you install Nethacker, it requires some dependencies to be installed on the operating system. There are some libraries such as SSL library or curl library, and please do read the manual on the wiki to which lists all the libraries that you need to pre-install on your operating system, whether that's Windows or Linux, to make sure that Nethacker's Python modules could be installed. But generally, to install OWASP Nettacker, just like any Python tool, you will just do a git clone from github.com/OWASP/Nettacker. Then you change your folder to the Nettacker directory, and then you run pip install -r requirements.txt, which will install all the Python dependencies. So that's basically how to install it. I recorded a video about how to install Nettacker version 002 in Kali Linux. If you're interested in installing it in Kali, you can watch that video, and also there are some instructions available on the wiki as well. And today during the demo, I will actually be showing Nettacker running on my Kali Linux VM. I'm pleased to tell you that Nettacker was chosen by the BlackArch Linux team. If you don't know what BlackArch Linux is, it's a distribution which is particularly targeting penetration testing consultants. So if you're a pen tester, probably you will be familiar with BlackArch. Completely out of the blue, I saw a tweet by one of the BlackArch Linux maintainers who said, we now include Nettacker in our standard distribution. I was really pleased to see this. So I downloaded and run BlackArch when I discovered that it's actually there. And if you are using BlackArch Linux, you can just simply type Nettacker and you will see it working there. It is included in the BlackArch automation bundle. You can see this is the actual version which is included. And this is all the BlackArch Linux tools where it already comes pre-installed if you install the full version of BlackArch. Nettacker will also run in Docker. There are no official OWASP image yet. We're working on it. It's coming soon, but you can compose your own. And again, how do you compose a Docker image? You just clone Nettacker if you haven't done it yet, and then you run docker compose up command, and that will create the Docker image and Docker container for you, and it will spin it up. Now, before we go any further, I would like to remind you of the responsible use of Nethacker, because Nethacker is actually an offensive security tool. So you shall not misuse this tool or any other security tool for unauthorized access. And it's a reminder that performing security scans without permission from the owner of the computer system is illegal. So always run Nethacker on networks for which you have permission to scan them. Remember when at the beginning I showed you the screen of the Nethacker, which had lots of text on it, and I couldn't understand what it was doing. Let me explain it to you so understand it. It's actually all very, very easy. Nethacker has 3 types of modules. It has modules of type scan, for example, port scan. So these are modules which perform scanning, right? Which is not necessarily vulnerability scanning. So port scan scans for open ports. It has modules of type vuln, which are vulnerability scanning modules. And for example, Apache Struts vuln is a name of a module which will be looking for Apache Struts vulnerability on your target system. And it has a module type of type brute. And these are the modules which perform brute forcing. So for example, SSH brute will try to brute force its way into the system using SSH protocol. That's it. So this is how easy it is. There are only 3 types of modules. You either scan for something, you either scan for vulnerability, or you perform brute forcing. And you can do it using different scanning methods. You can search for different vulnerabilities, and you can, of course, perform brute forcing using different protocols. So these are some examples of Nethacker scan modules. I've highlighted some of them with asterisks just to tell you quickly about them. For example, admin scan will perform a scan on the target system for any folders which might contain some administrative control panels. All right, so which can be useful to discover if you can find a particular tool which has admin control panel. Another module is CMS detection scan, will help you to detect what kind of content management system is running on the target. Directory scan is very similar to, for example, a directory buster tool, which used to be a tool from OWASP. And again, that's a tool which performs helps you to perform a scan for different folders, and again, find some hidden folders on the target. ICMP scan will basically scan the network and check which hosts respond to a ping command to ICMP, and we'll show you how long it takes them to respond. PMA scan is another very interesting module. It scans for phpMyAdmin. So PMA stands for phpMyAdmin. Why is this important? So phpMyAdmin is a very popular open source tool, which runs on hundreds of thousands of systems on the internet, and that's used by administrators to perform administrative tasks on MySQL databases. However, what happens is the phpMyAdmin's tool sometimes is installed with either default credentials or no credentials at all. And if a pen tester or discovers it, or an attacker discovers it, they can use phpMyAdmin as a tool from which they can pivot their way into your network. That's why it's quite an interesting module. Port scan is, as I told you before, just perform port scans. Another very, very useful scanning module is Subdomain Scan. Because Nethacker has a unique feature of performing subdomain scans and actually combining subdomain scans with all other modules. And there are a few other interesting modules. For example, Wapalizer scan will perform a scan using Wapalizer module. If you don't know what Wapalizer is, it's an analyzer system which can tell you what is running on the target server. So it will tell you whether it's running a particular programming language, whether that's PHP or Perl or Python, what kind of frameworks it's using, what kind of content management system it's using, what kind of JavaScript frameworks it's using. So it's trying to identify what is actually running. This is why it's quite useful for your recon and information gathering tasks. And then there's another module I want to highlight here is WordPress version scan that just tries to determine if the target is running WordPress and which version it's running. Again, why is it useful? Because older versions of WordPress usually have some known vulnerabilities, and some system administrators don't really like upgrading their WordPress because they customize it too much. And as a result, attackers can exploit vulnerabilities and hack into your network. Nethacker vulnerability modules, there are quite a lot of them. I'm not going to go through all of them. Actually, in version 003, we now have lots more modules. However, there are some modules that I would like to highlight here from the right-hand side. There's a module called Server Version Vuln. So this module checks if the target web server is leaking its version in the server header, in its the banner. There is also a very useful module called SSL Certificate Expired Vuln that helps you discover if there are any servers with expired SSL certificates on your network or in the target network that you are scanning. Why is this useful? If you have servers with expired SSL certificates and you haven't renewed them for a while, that usually means that the server is abandoned. And if a server is abandoned by your network administrators, that means that it's probably going to be unpatched. And if the server has not been patched for a while, that means probably there are some vulnerabilities that can be used to hack into that server. That's why it's actually quite a useful module to have, and a very useful tool in our Swiss Army knife arsenal. And another module I will be showing today is called X powered by vuln. Again, it's showing the contents of the X powered by header, which is returned by some of the application service, and that usually shows the name and the version of the framework. For example, if your server is running Microsoft .NET framework, this header will usually contain the version of the framework. If it's running a PHP language, it will also show the version of the PHP or whatever. So it actually allows us to perform some recon and figure out what is actually running on the server. That's why it's quite useful. And last but not least, it's the Nethacker brute forcing module. So Nethacker allows you to brute force into the target network using several protocols. So you can use brute forcing using FTP, using HTTP basic auth, using HTTP form. So HTTP form is basically your standard login screen on the web page, which has username and password. You can also brute force credentials using HTTP and TLM, SMTP protocol, SSH, Telnet, and the last brute forcing module is using WordPress XML RPC module to brute force its way into WordPress. So that's basically what Nethacker is. It's a collection of modules, and it either does scanning for a particular for subdomains or for ports, for open ports, and you can combine them with vulnerability scanning and brute forcing. Originally, Nethacker used to be called IoT Scanner because when it was created, the project leader, the original project leaders, envisaged that this tool is going to be used for scanning Internet of Things, devices, and networks. It can still be used for this purpose. I actually used it for finding out vulnerable cameras at one of my customers. I have a customer which is a large financial services organization, and they have cameras all over the place. They have cameras in their offices, on their premises, inside their data centers. And I quite simply used Nethacker to discover all these cameras, and I found all the ones which had weak credentials, which had like admin credentials, which allowed basically anyone to connect to these cameras and watch what's going on in these customers' offices, which is of course not good. So this is why originally Nethacker was called IoT Scan, and that's its logo. It's a little radar. You might see it on some of the documentation pages or information pages about Nethacker, so don't be surprised. And also, if you check the Twitter handle for Nethacker, it is still called IoT Scan. So the main module of Nethacker is a port scanner, and it's a port scanner which is written in Python. So unlike Nmap, which is binary, Nethacker's port scan is in Python, so it's very simple and quick to install, easy to use, and it's faster than Nmap. Actually, a lot of people in our industry in cybersecurity, they have this kind of a love and hate relationship with Nmap. To be honest, I don't like using Nmap. Since I started using Nethacker and became Nethacker's project co-leader, I almost completely dumped Nmap as a tool. I just use Nethacker because it's so much easier to use and easier to remember how to use the Nethacker options compared with Nmap. You can control how many threads Nethacker launches when it does a port scan using -t for number of threads and -m for number of threads per host. Nethacker is using Python multi-threading model. So again, it's only limited by the amount of the resources you have on the machine on which you're running it. And for example, if you want to scan for particular ports, you would use the -g command line switch, and then you can list the port numbers either using a comma. For example, if you want to scan just the port 80 and 443, you will use a comma, or using a dash to define a range. If you don't specify -g parameter, Nethacker by default will scan for 1,000 most popular ports, and these are the same, I think, the same 1,000 ports that Nmap is using. So it's basically the same idea. So how do you run Nethacker? As you remember, first time when I run Nethacker, I just run Nethacker with no parameters. It showed me a long list of the usage instructions, which I didn't understand. I closed it and I didn't look at it for a while. So in order for you to avoid this mistake that I made, I can tell you how to run Nethacker. So Nethacker requires 2 parameters to run. So it needs to have a target. What are you going to scan? And it needs to have a module. Which module you're going to be scanning your target with. That's it. So this is very, very simple. So for example, if you want to scan an IP address 192.168.1.149, you just specify -i parameter for your target, and then -m for your module that you want to use. For example, port scan. Again, if you want to scan the whole network instead of one IP address, you can define the network with /24, and Nethacker will scan all the 255 addresses using this particular module. Nethacker actually supports several types of targets. So you can define a single IP address, that's simple. You can define a range of IP addresses with a start IP address and an end IP address. You can define the whole network using CIDR notation, so using / and the bits. You can also define a domain name as a target. So for example, OWASP.org can all be scanned. You can also define a URL using HTTP or HTTPS. If you're scanning a specific URL for a specific vulnerability, this is very useful rather than scanning the whole network. If you know the URL that you're after, much quicker just to define a URL. Additionally, you can also put a list of targets in a text file, and instead of -i parameter, use -l for the list and load the list of targets from a text file. Again, why is this useful? If you are working for a larger organization, then you know that the larger enterprises will have several domain names. They will have several networks, several IP address ranges, and you can scan them all with one command. All you have to do is just put them all into one text file and load that text file using Nethacker-l command. Very, very simple. And another great thing about Nethacker is that you can chain modules. So you can use more than one module and you can pull more than one blade out of your Swiss Army knife. And what you need to do for that, you can just, if you want to run, for example, on 192.160.1149, 2 modules, port scanner, and phpMyAdmin scan, you just list them with a comma and it will do it. Right, so this is how simple this is. And You can also create profiles, and profiles basically are bundles of modules. So if you're using several modules together all the time, or if you are preparing a scan for a particular engagement, for example, if you're doing a penetration testing task, you can create your own custom modules and put your favorite modules which are performing the task that you're after together in one profile. However, by default, Nethacker comes with several profiles. These profiles are info. So info has all the information gathering modules in one bundle. There is a profile called scan, which combines all the scanning modules in a bundle. There's a brute, which combines all the brute forcing modules, and vuln, which combines all the vulnerability modules in one profile. So you can just, if you want to run all the vulnerability modules, you can just say Nettacker-I, define target, and -- profile, and then vuln will do the vulnerability. Info will only use only information gathering modules. There are two additional built-in profiles. One is called WP for WordPress. So that will use all the WordPress scanning modules available in Nettacker. And Joomla will use all the Joomla content management system scanning modules. And there's a one magic profile name called all, which means Nettacker is going to use all modules, absolutely all of them on the target. Of course, that will take probably quite some time to scan using all the modules, but the option to use all modules is there and it is available. So for example, if you were to scan just one website with all modules, that makes Nettacker quite similar to OWASP Zap or Burp Suite. But if you are using as a target multiple IP addresses, IP ranges, networks, or subdomains, then that's what makes Nettacker different. So I'm going to show you live demo how to use Nettacker. I'm going to do it in my Kali Linux. Let me switch to my Kali. All right. I already have Nettacker pre-installed here. You can just list the folder. You can see this is a whole bunch of files, including nettacker.py, which is the main Python file for Nettacker. You can, older version of Nettacker, this is version 002. Let me just show it on the screen. Version 002 runs under both Python 2 and Python 3. So I can run Nettacker under Python 2 or Python 3. So you can see, as I showed at the beginning of my presentation, when you run Nettacker, it just shows us usage instructions and tells you about various command line options, tells you the fact that you can use multiple languages, you can call help, you can use wizard. There's lots of things here, including the list of all the modules available. But this is all of course quite confusing until you figure out how to use it. And this is how you use it. Okay, let's switch to Python 3 here, and let's perform a simple task of port scanning. So I have a host on my network, which is 192.168.132.178, and I want to perform a port scanning on it. So I provide a -I, and I provided the IP address of the destination. And if I say port scan, this will launch Nettacker. It will tell you which version we are running. And then you can see very quickly, it performed the port scan. That's it. So it scanned the target. You can see these are all the open ports on the target. You can see this particular IP address had quite a few open ports, but it doesn't have to be an IP address. We can, for example, scan owasp.org. Let's see, what do we have open on owasp.org? I expect it's probably just going to have the standard web ports, but you never know. Again, you can see here when Nettacker starts, it will also check for its latest version. As I told you, I'm currently using version 002 for this demo. However, the latest and greatest version of OWASP Nettacker is 003. And I'm not using it because it has some fundamentally different features, and it's also not quite stable. So there you go. You can see that OWASP.org is only running for ports 80 and 443. So what else can Nettacker do? Another interesting thing we can do with OWASP.org is we can perform a subdomain scan. Let's have a look at the subdomain scan. What this module will do, it will try to discover all the subdomains of the target domain. You can see these are all the subdomains of OWASP.org that Nethacker has managed to find. You can see there's quite a lot of them. Okay, and you will also see some interesting thing that when the Nethacker runs, the results are displayed in this text tabular format where you can see the host. So this will usually be the host on which the scan was performed. Username and password columns are reserved for brute force modules. So if when you're running brute forcing, you're running it against a dictionary of credentials. And if any of the credentials actually worked on the particular target, they will be displayed here. There's also a port column for, you can see previously when I performed the port scan here, if the port was open, then you will see the number of the port. Then you see in the type, you will see which module type was used. So that's the name of the module. And in the description, you'll see some additional information, right? So for example, in the port scan here that I performed earlier, you could see that the description of the port 80 was HTTP TCP connect, which means we managed to connect to the port using TCP, and the response looked like an HTTP server. And if I show you the previous scans here, where I performed here on my server, you will see that some of the ports here, port 8084 and port 8090 were also running HTTP server. Again, why is this important? And again, that you can have some of the popular services running on some obscure ports. Like here you have HTTP running on port 8084 instead of port 80 or port 443. And again, I've seen a lot of networks where developers are trying to hide their SSH access. It usually happens in some of the cloud instances in AWS, where instead of running SSH on port 822, some system administrators will run it on some obscure port on, I don't know, 8822, for example, but it is actually an SSH. So Nethacker has its own database of signatures. It's trying to identify what kind of service is running behind a particular port. And if it manages to identify what it is, it will actually display it. So that's what is actually displayed in this list. So let me now show you something else. Obviously, you've seen how we can do subdomain scan, but let me now show you another module, which is called server version vuln. Okay, so this module will try to identify if the type of the web server that the target is running, and it's doing it by looking at the server header in the response. You can see that OWASP.org is actually running Cloudflare. Interesting. Let me add another module here, because as you see, we can actually bundle several modules together and chain them. I'm going to add X powered by module. So X powered by will try to see if there's also an X powered by header, and we can see there is one, and it's actually saying that it's powered by rank sense. Okay, interesting. But if you look at it, it's actually only telling us about one host, which is OWASP.org. However, OWASP Nettacker has a fantastic feature where you can run any of the modules. That can be one module or a combination of modules or the whole profile on the whole subdomain. And that's what makes it such a great tool. So in order to utilize this feature, all you have to do, just have to add -s as a parameter. It simply stands for subdomain. So what's going to happen now is Nethacker is going to first discover all the subdomains of OWASP.org. And now it's going to use these two modules that I use, the server version discovery and X powered by discovery on all subdomains. And you can see how quickly it actually generated this report for us, which is absolutely fantastic. It tells us now everything that OWASP is running. A quick caveat, a disclaimer, the reason that I'm showing you OWASP.org because I'm allowed to scan it, because OWASP has a bug bounty program and it is allowing security researchers to scan its domain. Again, a reminder, do not use Nethacker on the networks for which you do not have permission to scan. Only use it on the systems for which you do have an explicit permission to scan, or if these networks have bug bounty program which allowing scans performed on the subdomain. In this case, what Nethacker did, it first discovered all the subdomains, then it tried to connect to port 80 and 443 on each of the OWASP subdomains, and then it said, okay, does the response contain the server header? If yes, it displayed the server header. You see, sometimes it was a Cloudflare. For example, this one had Atlassian proxy. Does the server also have X powered by? So if there is an X powered by, it will be displayed. Okay, so here's another great feature of Nethacker. You can see after it finished displaying it, it says report saved in this HTML file and database. So why is this important? So first of all, every single scan you perform with Nethacker is not lost. It is saved in the local database by default. Nethacker comes with SQLite database. However, you can use other databases. I will tell you about this a little bit later, but have a look at this report. So this is HTML report. Let me actually take a look at this. So let me copy the name of this file. And because I have Firefox here on my Kali Linux, let me see if I can open this HTML file on Firefox. And here you will find a fantastic feature of Nethacker, which is a penetration testing graph. So HTML reports have this graph feature, which shows you what happens when attack started. And you can see this is the start of the attack. Then you will see all the discovered subdomains that we discovered, and then you will see all the modules which were run, and then you will see the result of the scan of each module. Why the graph feature is quite useful? Because you can instantly see any irregularities in it. And for example, I can see here, right? For example, have a look at this. So for example, all other hosts, they had like two branches, right? They had server version val and X powered by. But this one, OCMS OWASP.org and secure flag OWASP.org, they only had a hit on server version val, so there was no response from X powered by, right? So by looking at the picture, you can instantly identify this visually. What comes after the graph is the same results you've seen in a text format, but this is in a tabular format in HTML, and you can see the same results, all the data, and there's a little bit of a visual effect here. If I hover over a particular row of data, it blurs everything else just to make sure that you focus on a particular row of data. So this is absolutely great. So we can get this data in nice HTML format, but that is not it, because Nethacker also can save results in some other formats. So we've seen the HTML and graphs. However, Nethacker can also output its results, not just in HTML. It also has a JSON output and CSV output. And why is this great? So JSON output is great because it's structured data. And because it's structured data, that means that the results of Nethacker scans can be consumed by other tools, whether that's cybersecurity tools or any data processing tools, because JSON can be read and understood by many, many other tools as a structured data. And of course, the great thing about CSV format is that it is actually a spreadsheet format. And I'm going to show you how to use it. In order to generate the results in the report in CSV, all we have to do, we just have to repeat the same command that we use to run Nethacker, using whatever options and modules you want, but you add -o parameter. And -o simply means output. And you can go and say, well, I want to have a report, and you can put any file name here. I don't know, for example, I want to call it report OWASP, right? Because I'm scanning OWASP here. So if I put .json as a file extension, I will get a result in JSON format. If I put HTML here, I will get a report in HTML format. If I put TXT here, I will get the result in text format. And if I put CSV, I will get result in CSV format. So let's run it in CSV. So first of all, you will see an interesting message which says graph feature is not available because the report is not HTML. Fair enough, because CSV is just a spreadsheet without any pictures. You can see how quickly the scan was done on the whole of OWASP.org domain. And we get report saved in report OWASP and database. So because the CSV file is now here, I have a open source Office on my Kali Linux called LibreOffice. And LibreOffice has its own spreadsheet program called Calc. So if I now try to open the spreadsheet, let's see what we get. Okay, it tells us that we need to import it first. And there you go, lo and behold, we got a spreadsheet. What is this? This is a spreadsheet of all our network assets on OWASP.org. Of course, in your case, you will use it on your own subdomain, or if you are using Nethacker for penetration testing or bug bounty engagement, you will have all the assets of the target. So let me first talk to you about a few of the extra columns that you can see here. You can see an extra column here called scan ID. So scan ID is basically unique identifier of the scan. Why it's there? It allows us to quickly identify all the results performed within a particular scan in the database. Right. So usually we don't need it, so you can delete it or hide it. Same thing with username and password. Right. So if we were performing any brute forcing modules, we will be able to see username and password. And I'll just delete it. But here we have, well, it's fantastic, a spreadsheet of all our assets. And because it's a spreadsheet, we can manipulate it as a spreadsheet, and we can use the data filtering tools, for example, right? So we can perform any sorting or filtering. And here, for example, just like in any spreadsheet, if I want to go and say, okay, show me all the OWASP assets which were running Atlassian proxy. See, we spotted there were a couple of them running Atlassian proxy. What was it? And there you go. We can see that it was Contact, NOCMS, and Atlassian proxy was running on both versions 80 and 443. And there was also something which was running Nginx. What was it? Let's go and have a look. Which asset of OWASP was running Nginx? And that was Secure Flag. Again, you can see it was running it on two ports, port 443 and port 80. So you can just use this. And again, you can use data filtering tools with spreadsheet. And this is a very, very cool feature. This is probably the only tool that I know, security tool, which actually gives you output in Excel. And this is fantastic. Why? This is a manager's dream. You get your report in a spreadsheet. Nethacker allows you to scan your network and discover all the assets that you have and put them in a nice and understandable format of a spreadsheet. So why is this also important, right? A few years ago in 2017, when we were talking about the previous installment of OWASP Top 10, our Appsec industry veteran and very famous person in cybersecurity industry, Jeremiah Grossman, who is one of the founders of Application Security, of course, CEO of White Hat, which was one of the first application security company, about 22 years ago. So he tweeted in 2017 and said, I suggest that the OWASP Top 10 includes A0 or asset inventory. You know, these days, the biggest Appsec risk are websites you don't know you own, right? And I keep hearing it over and over, right? So a lot of organizations, they don't know what they have. And this is actually a very big problem, because if you don't know what you own, you cannot possibly secure it. And Nethacker actually solves this problem for you because it allows you to discover all your assets. That is not it. Nethacker also has a great feature. So it has a web UI and an API. So you can run it in an API mode. And in this mode, you don't need to use any command line. You can just use a web browser. All you have to do is run Nethacker with --start API option. When it starts up, it will show an API key. You will need this, so make sure you copy it. And then you can just connect it with a browser. Let me quickly show you how this works. So in order to do this, let me quit my spreadsheet. So I will run Nethacker. Let me delete all the options here. And all I'm going to do is just say --start--API. As you can see, Nethacker starts and pauses here. It says it's now running on HTTPS 127.0.0.1 port 5000. That's its default port. And it gives us this API key. Let's copy this API key and let us open a web browser. So we have Firefox here on Kali Linux. And let's try to connect to 127.0.0.1, not 3000. I want 5000, please. And I want it HTTPS. Okay. So we instantly get the browser warning telling us that this website is using self-signed certificate. That's fine. If you want to use a proper signed certificate, Nethacker actually gives you this option. We can accept the risk and continue. And we will end up looking at the Nethacker web UI, where you will see several buttons. You'll see tutorial, crawler, results, new scan, field for API key, and set session. So if I click on new scan, you will see I can't do it because it'll say, please log in first. This is where we need our API key. So OWASP Web UI does not require any usernames or passwords. You log into it using an API key because it is actually an API mode. Once we put the API key in, it says success, your session was successful. And now we can click on the results button. And this is where you will see that all the previous scans that I've done, they are all visible here, right? This is because every single scan that you perform is done in the data, is saved in the database. And we can see, for example, that this command was run using the command line, right? When I was running the server version vuln nx powered by. But for example, if I also want to run a similar thing using a web UI, I can just click on the new scan button and see how we can do it very easily here. Okay, I want to scan owas.org. I'll just type owas.org. Okay, I can add more targets here if I want. These are my profiles, and you can see they're color coded. So if I say use a scan profile, it's color coded green, and you can see all the green modules, all the scanning modules light up. If I want to use vulnerability profile, you can see they're all color coded red, they all light up. And if I want to use brute forcing module, you can see all the orange modules light up. So this is very simple. So if I want to reproduce the scan that I've just done, so I've used server version vuln, right, on owas.org, right, which was one of the vulnerabilities that I used, and X powered by. So I used two modules, as you remember. So if I want to use two modules again, I just tick these two boxes. I'll tick the type of the graph that I want. I can change the language. I recently presented at OWASP Latin America, at OWASP Latam, and I changed the language to Spanish. And all the screens were shown in Spanish. And I was told that 90% of the text was correct, 10% had some grammatical issues. So I told them that they can go and contribute and fix this. But let's switch to the advanced tab. So we chose two modules, but I actually want to perform the scan on all the subdomains. So in here, I can actually tick the box for check subdomains, which is equivalent to the -s command. So once I do this and I just click on the submit button, you will see success request submitted. It goes into the API. After a few seconds, you can see it disappears. And now we can return back to the results and simply wait for our results to finish. You can see this is our scan number 9, and you can see scan number 8 that we performed was run using command line, and you can see the command line that I used. But the latest scan was run through the OWASP Nettacker API. And if I click on it, I will see the same results, but now I perform them using the web UI. Another great thing about using the database that you can always get back to any of the previous scans. So for example, remember I done a port scan at the beginning of my live demo here. You can see this is a port scan. I don't want to look at the owas.org. Let's look at this one. There you go. You can see that I had 5 ports open on this machine. You can see it's in tabular format. But what is also great about Web UI, I can download this data as a CSV. So I can download it as a spreadsheet straight away. And I can open it and view it in my favorite spreadsheet system. There you go. So that's how easy Nettacker can be used. So yeah, these are just a few slides which tell you about how web UI can be used. So another interesting thing about Nettacker is that we actually used it to for quick response to an Exchange server vulnerability, which was the biggest cybersecurity story of the year this year, because in March, if you remember, there was a Chinese state-sponsored threat actor called Hafnium, and they were exploiting the vulnerability in Exchange server, and they were hacking lots of Exchange servers and web Outlook pages which were exposed on the internet. So days after this article was published, we released a module, and you can see I tweeted here and I said that the OWASP Nettacker free and open source tool now has a module which allows you to scan the network and find this critical Microsoft Exchange CVE vulnerability. And I wrote a blog article about this. Okay, and this is how simply you could scan and discover it. So I'm running short of time, so I'm just gonna summarize how you can use Nettacker. So you can use Nettacker for asset discovery. You can scan your network for open ports. You can scan a network for new hosts. You can scan your network for default credentials. So how many devices on your network will respond to admin if you connect to them using SSH or HTTP or FTP or SMTP. You can scan the whole network for a specific vulnerability. For example, Microsoft Exchange CVE that I showed you, you can discover all the vulnerable devices. You can monitor subdomains and open ports on them. You can discover expired SSL certificates. And you can find subdomains hosting vulnerable versions of WordPress, Drupal, and Joomla. So everybody knows OWASP Top 10. But there is another OWASP Top 10 that you probably know nothing about. There is a top 10 of most starred OWASP repos. So what is a starred repo? So users of GitHub place a star of other people's repositories to save them in their bookmarks. Right? It also indicates that they like this project, or they just would like to bookmark it. And GitHub stars, it's an easy metric to keep track of, and can be used how popular a particular open source project is. And if you look at all the OWASP repositories on GitHub, you will find that number one is Cheat Sheet series with 18,000 GitHub stars. So 18,000 people bookmarked it and liked it. But you will see that Nettacker is actually number 10 in the top 10. We now have over 1,400 stars, which is absolutely fantastic. So I do invite you to go and check it out. And if you like it, you can star it, and we will have one more star. And you can see all the stargazes by going to this URL. I'm going to tell you about the latest version of Nettacker, version 003, which was completely re-architected, and our modules now are defined not in Python, but as YAML files. This will allow us to very, very quickly respond and create new modules. And it will also allow you to get Nettacker and create your own module for discovering a particular vulnerability or performing a particular scan. It makes it very easy and customizable because YAML files are text files. And this is an example of how a YAML file can be created. So how to contribute? If you would like to contribute, we welcome all the contributions. Please do read the developer wiki before you submit your pull request. Please follow contributor guidelines. And you don't have to submit Python code. You can also help us with translations or documentation. So this is it. Nettacker allows you to attack your network before the real attackers do. And thank you very much for having me. Now I'm ready to take some questions. All right, let me check if I had any questions. Okay.
Please feel free to type that if you have any questions on the Q&A, and Samurai can read those out loud and he can answer.
I'm not seeing any questions at the moment. One of the questions, which is, okay, I can see one. So the brute force attack module, all the rest modules only for detecting purposes. Yes, and the brute force module allows you to define dictionaries of usernames and passwords, and it will try them all until it finds a match. That's what brute force attack module does. There's another question: what does it take to develop a new vulnerability module? You just need to define the attack, right? So for detection, so what you need to send. So there's a payload that you send to the target, and what do you expect to receive in response? So both can be done using regular expressions. So if you send a particular string in your request, what do you expect to see in the response? For example, for Microsoft Exchange Server, there's a particular combination of the symbols that if they are returned, that means that there is a remote code execution. For example, the request might contain dump your etc password file from the machine, or dump your system.ini file from Windows server, and a regex to check a vulnerability would be to look for a particular string in response. Is there a way to get a feed of new vulnerabilities? So that's not what Nethacker does in terms of the feed. You can get a feed from a CV database, from NIST. Usually it will not actually tell you about exploits, but a lot of people have released exploits on GitHub, and you can just discover them by searching Twitter. And that's how our team, Nethacker team, discovers them. And we write vulnerability modules according to these proofs of concepts, which are released by the researchers. The question is, there a headless engine there when it comes to crawl web applications? It doesn't actually, well, there is some crawling, and this is done for example, for coarse vulnerabilities, or for discovering some JavaScript endpoints. That's actually, I think it's using Phantom.js. Okay, I think that was the last question. Thanks very much, everyone.
Thank you, everyone. And now thank you so much, Sam, for everything. Now we're going to actually move on to our second speakers, and that's going to be, we have Deepfactor CEO, Kieran Camedy, and we also have Andrew and Seth with us, and we'll have them set up. So just give us a few minutes to get them set up right now.
Cool. Can you hear me okay, Wendy?
Yes, I can.
Great. Kieran, do you want to do a quick voice and
check? Can you guys
check? Yeah.
You can hear me?
Yes,
yes,
we can hear you.
Yes, we can hear you.
Okay, cool.
I think I'm ready to go. I was trying to briefly figure out why my Deepfactor background is not showing up, but that is hardly an important thing right now.
But your slides are not showing either. So.
Yeah, I need to share. Yes.
Yes.
All right. Where is Zoom?
While you're bringing that up, I really enjoyed watching the Nethacker demo. Thank you for that, Sam.
Sorry, I'm trying to find the the toolbar. I don't know where it is. There we go. All right. Can you guys see my screen?
Yes,
Yeah.
we can.
Great. All right. My name is Andrew Horgan. Thanks for the introduction, Wendy. I am based over in North Carolina, and I'm joined by Kieran and Seth, who are both in, well, the Bay Area-esque, which I'm sure Seth doesn't like me describing wine country as anywhere near the Bay Area, but we'll stick with it. We work for a company called Deepfactor. We are a remote first company, so we're all over the United States and India. I'll let Kieran give you a little bit more detail about Deepfactor and who we are and why we're here talking to you guys today. We are going to generally just be kind of talking about the evolution of Appsec tooling. This is a session that we've done with other meetups, and some of it is, I'll say, 101 level, but it's also an opportunity for us to take a step back and really just look at where the industry is headed. Kieran brings with him a wealth of experience across multiple different types of technologies and companies, and I think that we have a unique perspective on what is happening in the sort of AppSec environment. So with that, I'll hand it over to Kieran to give us a quick introduction on what is Deepfactor.
Awesome. Yeah, thank you, everyone. And the goal for today's presentation is not to do a sales pitch. So this is the only customary slide that we're going to do about Deepfactor. The rest of it is going to be really thought leadership around where AppSec is headed and how the different tools are evolving and what is the right tool to use for your application, your environment, so on and so forth.
Sorry, Kieran.
So the customary Deepfactor slide is we're a remote first company. So we're a company that was started during the COVID time. So basically we're 100% remote in the US. The teams in the US are 100% remote, but we do have an India office that is centered in Bangalore. The DNA of the team is extremely centered around cloud native software development, security, and DevOps. I personally came from Cisco. That was my previous job. And there were several other members of the team. Leadership team came from Citrix, IBM, Qualys, HP, etc. So lots of deep knowledge in both cloud native application development as well as Appsec. What Deepfactor is we are a next generation application security platform that is designed for cloud native applications. And at the heart of the product, it is powered by observability. And we'll touch upon what that means during the course of this presentation. There are three fundamental unique things about Deepfactor. One is it's designed with a cloud native first mindset. So if you are if you're deploying your application in a Kubernetes environment or other cloud native technologies, then it's very easy for you to just drop Deepfactor into your kube cluster or into your container image. And it does a variety of things that, which is why we call it unified AppSec. It scans your container images, it gives you a bill of materials, it does your software composition analysis, but it also observes your application, every pod in your containerized environment at runtime. And therefore, it provides this unified kind of view into your AppSec that has software composition analysis, container image scanning, DAST, IAST, and software bill of materials in one integrated kind of experience. So if you are working for an organization that is used to how AppSec tools have evolved over the last 20 years, which is, DAST came along, SCA came along, so on and so forth, and you're used to putting in 5-6 different tools into your CI pipeline. What we have done is taken a complete step back and say, okay, now is a good time as you're going through digital transformation initiatives and containerizing your applications and moving away from legacy, it's a good time to rethink how you do your AppSec as well. And so we built a clean slate platform that is designed for cloud native, although it does work with legacy workloads as well. It's primarily shines with cloud native workloads, provides that unified view into AppSec. And at the heart of it, it is powered by runtime observability. That means when you turn on Deepfactor in your Kubernetes cluster or your application, it watches every pod or every container running in that environment, and therefore takes that rich telemetry that is coming in from that application to provide you not only visibility into runtime insights, but it also helps you prioritize your software composition analysis or container image scanning findings with runtime information so that you can prioritize them and reduce the alert volume that you then need to feed back into your dev teams. So that is the less than 5-minute customary overview of Deepfactor. So let's go through the rest of the deck.
Great, thanks, Kieran. So taking a step back, right? Kieran kind of jumped ahead to the end state of why we founded and made, Kieran and Mike founded Deepfactor and kind of got started. And part of the reason was taking a good hard look at where the industry started in terms of the evolution of the software development lifecycle and where it was headed. So this is a really high level view of where we saw the industry evolve. So we kind of started out obviously with continuous integration, the idea of building fast. And because we were building fast, we were able to then turn our focus into continuous deployment. Those were, really married together. If you're able to build faster, then there's going to be this prevailing need to deploy faster. It was along that process that we learned, well, hey, if we're going to build fast and we're going to want to deploy fast, then we better test fast. A lot of the focus when it comes to continuous testing is the idea of validating your features, right? So it's not so much on Appsec. Honestly, it's not always in terms of scalability. It's generally, does the feature do what I expect it to do? So we're building fast, we're shipping fast, and we're validating quickly. Now, one of the things that happened, I think, more quickly than others is we realized, hey, we're putting things into production very quickly. And we don't have a lot of visibility into the sort of things that might go wrong that maybe we didn't catch during the sort of validation step, the testing step of the staging environment. And so you saw the rise of a lot of platforms like APM, for example, application performance monitoring, container security more recently, and they're really focused on operating the platform. Right. So if you're talking about a Kubernetes cluster, you might have some sidecars that are observing the network traffic. If you're talking about a APM, like a App Dynamics or a Dynatrace, you might have an agent that's running alongside your application that understands the language, right? Understands what the application is trying to do, and it's feeding you metrics. There's also optimization that kind of gets rolled up into this, right? So you can look at products like Dynatrace a little bit. But Turbonomics has made a big name for themselves in this space where they're monitoring their application and they're trying and your workloads and trying to give you recommendations on right sizing, for example, if you're in a cloud environment. Now, one of the things that we noticed as we started to validate what Defactor was hoping to accomplish was this kind of this friction that was existing where everybody was trying to move as quickly as possible. They were trying to build quickly. They were trying to validate quickly. They were trying to deploy quickly. But we had almost these manual checkpoints, right? And sometimes they weren't exactly manual, but they were so tedious, right? Where you're statically gating releases based on application security requirements. So you might do a scan with an SCA tool and hold for any vulnerabilities. You might put it into a staging environment and use something like an IAST or a DAST to exercise the app, and then statically, gate it again before you ever get into production. So you had these opposing forces that were kind of competing with each other. Now, at Defactor, we like to think about, well, what about everything in between, right? So how do you get past, how do you jump over these fences, these gates that you've kind of created for yourself and circumvent them, but still have that sort of application security minded release cycle? And that's what we like to talk about, continuous AppSec. The idea that you're securing your application as quickly as possible. So, you want to be able to build quickly, but you also want to be able to deploy quickly, but you want to do it securely. And so, we are starting to see a shift in the market, and we're not the only ones doing it, right? Where we're focusing on this idea of securing the application during the CI/CD pipeline.
So why is this an important problem to solve now? So maybe a good time to kind of touch upon the growth of the change in the application landscape that we're seeing. We're seeing a few trends, and you guys are, AppSec experts. So I'm sure many of this is not news to you. You already know this. Number one, we're seeing an increase in the number of security breaches. We're also seeing an increase in the magnitude of breaches in the recent years, as some of these graphs kind of show you. Secondly, we're seeing a rapid increase in the number of cloud native applications that are being developed. One of the stats that I learned at KubeCon last week in Los Angeles was that I believe the number of cloud native applications that we will have as an industry by 2025 is going to touch 500 million. And that's a lot of cloud native applications. And we have 190 million plus GitHub repos. So lots of code being written. The number of developers is skyrocketing. We today have about 26 million developers worldwide, all languages put together. And that number is supposed to get to like 45 million plus by 2030 because every company is a software company. So basically what's happening is we are seeing a lot of code being written, a lot of cloud native applications being developed, a lot of legacy applications being torn apart and put into microservices and cloud native deployments. All because people want to move fast. Businesses want their applications to new features to be added to their applications and deployed really, really fast. And we're putting all of this in the CI pipeline. So there's basically what we're saying is apps are becoming more complex. There's more code being written and they're moving at a super fast pace. So there's no way humanly possible for us to catch all of the security risks in your application if we still rely on the old ways of doing Appsec, especially if the old ways involve waiting for the Appsec person who gates the releases or the Appsec team who gates the releases and then identify security issues. Those days are gone. We all know that. So it's important for us to bake in security visibility into the CI pipeline itself, so that just like how we automatically test the functionality of applications, like what Andrew showed in the previous slide, we need to automatically identify security risks in the applications, both in the code that your devs are writing, as well as in the code that in the third-party code that they're bringing in, which apparently is the stat is around 75% of most applications these days, especially web applications, are third-party code. So that, in a nutshell, summarizes the challenges around Appsec, considering digital transformation initiatives that are happening these days. And therefore, what do we need to do as an Appsec community to bring visibility into security early on in the pipeline is to bake these things into the CI pipeline. But it's not it's not an easy thing to do because there's multiple different attack vectors, multiple types of applications. You need to figure out what is the right thing for your company, for your applications that you're creating. So the most important thing right now to understand that we want to touch upon in this presentation is the availability of tooling that we have. It's important to bake these tooling, identify the right tools that make sense for your application, your team, and put that in the CI pipeline. But what tools make sense for your app? There's plenty of tools out there, lots of acronyms being thrown, and many of you guys are Appsec experts, so you probably know a lot of these tools. So let's walk through quickly the evolution of some of these tooling that has happened over the last couple of decades. When I was just getting into workforce, pen testing was a thing, right? So 20 years ago, you had pen testing was started around that time, and then it still to this date is an important aspect of a checkbox that it needs to be put into your application, where an external third party has come in and audited your application, both did black box as well as white box approaches, identifying the issues that exist in your application, and possibly also identify compliance issues in some of the pen tests, depending on which pen tester you pick, and therefore give you a summary. Useful, but you need something faster because we just established that we need that visibility into the CI pipeline. But 15 years or so ago, in the early 2000s, you had DAST tools that kind of came to the market. Maybe Web Inspectors, which is it was probably one of the earlier DAST kind of tools. And currently OWASP Zap, this especially the OWASP community following, Sam talked about that in the previous presentation as well. DAST tools are great. Short for the non-Appsec people in this audience, DAST stands for Dynamic Application Security Testing. Allows you to test your application from the outside. So basically poke at the web service or endpoint that your application is exposing, crawl through the web interfaces, identify OWASP top 10 or related vulnerabilities that exist in your application. It's not yet looking in your code. It's not looking in your build images. It's not looking inside your app, but it's poking your application from the outside, treating your application like a black box. Important, but not sufficient. Then came SAST tools, static application security testing tools that allowed you to scan your code and identify the issues that exist in your code. Coverity, which was later acquired by Synopsys, was a great example. It came from some of my buddies at Stanford when I was in the grad program there. That's when Coverity was, I think, was created around that time. So it's a good, SAST is a necessary technology. It helps you identify, especially these days. I think it helps you identify things like secrets in your code and whatnot. And of course other vulnerabilities too. Then came software composition analysis. SAST identifies issues in your code, the code that your devs are writing. Many times it gives you a theoretical list of all the things that could possibly go wrong with your application because it's looking at everything that is checked into your repo. So naturally, the list of things that SAST produces is a long list. So there are many dev teams that are sometimes overwhelmed with the volume of SAST tooling. Software composition analysis, on the other hand, tries to identify issues that exist in a third-party code that is being brought into your application. And the way SCA tools typically identify that is by looking at publicly available vulnerability databases that identify CVEs, short for common vulnerabilities and exposures. NIST is a great example. Yeah, it has a public database. There's a few other public databases out there, and there's obviously some commercial databases like Synopsys, Black Duck, and whatnot that claim to add some more meat to that database by identifying some of the CVEs sooner, shorter release cycle, 0 days, and so on and so forth. So SCA is a great way to identify vulnerabilities in your third parties that the devs are bringing in by looking at known vulnerability list that exists in the publicly available databases or commercial databases out there. Necessary as well, but not sufficient. These days, we're creating container images, especially with cloud native applications. So it's not only important to identify the dependencies that exist in your jar files or in your NPM packages, but it's also important for you to identify the list of packages that have been bundled into your container image. So container image scanning, JFrog X-ray is a great tool that allows you to scan your container images that are checked into your repo and then tells you these are the vulnerabilities that exist in your container image. The next set of technologies that came along is interactive application security testing. Because SAST and SCA and container image scanning were looking at the static aspect of your applications. They were not yet running your application. DAST was looking at your running application, but it was poking the application from the outside. It wasn't looking inside the application. But what's going on inside the application? You need to find that out, because that's, there needs to be a way to identify things by looking inside your application, because you identify more things, and you also, identify evidence information that you can then tag along to your SCA or SAST and say, okay, these are the things that are more important because I observed that your application actually did it. So IAST came along about 10 years ago. I think Contrast Security and companies like that, one of the leaders of the IAST, category of tooling. And they provide a language-specific way to insert an agent into your application. For example, if you have Java, then you have a Java agent. If you have a Node.js application, then you create a Node.js agent, and you bake that into your application or image. And when you run it, it observes the application from the outside and tries to find issues. It doesn't scale really well to cloud native workloads, which is where observability came along. Observability is a novel way to identify what's happening inside your application in a language agnostic manner, especially if your application is a cloud native application. Then observability really shines, because if you have 20 pods, or for example, in your containerized application, then with a technology like an IaaS, which was designed pre-DevOps, pre-Kubernetes, you don't want to go crack open each of those containers and then container images and then try to identify which language it's written in and then start to instrument each of them. It becomes very cumbersome and honestly untenable. So observability is the best way to identify your running application's behavior if you're a cloud native application. So what you do is you drop Deepfactor or any observability platform out there into your kube cluster or into your or run it alongside your containerized application, and it watches the various pods, and you just say watch these 20 pods, and then it watches all of these processes that are running inside your pods, identifies the process behaviors, memory behaviors, down to the system call level, all the way up to the web level, web behaviors and file behaviors and whatnot. And then it condenses all of that rich telemetry, either sends it over to a portal or some backend where data is analyzed, and then insights are presented across these various behaviors. It can not only be used to find and identify runtime behaviors, it can also be used to complement your bill of materials or software composition or container image scanning by layering on top of the findings of your SBOM or software composition analysis, runtime findings. Like, for example, we can say, okay, this is my bill of materials, but these are the things, these are the vulnerable packages that we found were actually used by your application. Here's the function that was called, and here's the class path that was executed. So it'll help you not only find new things based on runtime behavior, but also helps you make your SCA better. It helps you make your container image scanning better. It helps you make your DAST better with richer evidence information as well. So that's kind of the evolution of these tooling. Each of these tools, also have some downsides. So depending on which tool makes sense for your organization, you need to pick the one that makes sense. So, pen tests are often expensive, tedious, require third parties, and you have to wait for the 6-monthly pen tester for budget reasons primarily, and anything, as well as bringing in a third party and the logistical aspects of it. DAST tools are great. The first generation of DAST tooling really was slow, took a lot of scan times. These days, you're seeing some of the up and coming DAST tools, like a Neural Legion, for example, that allows you to scan quickly and is designed more for CI world. SAST and SCA tools are great, but they lack visibility into the running application, which means the natural result is a high volume of alerts, and you've got to watch out for that. You've got to complement that with other tools like IAST or Observability. IAST tools are good if you have a legacy application or a, such as a .NET application or something like that, or if you clearly have a small list of applications, or you have a monolithic application that you clearly know what language it's written in. Then it makes sense. Otherwise, agents can be difficult to scale, especially with cloud native workloads. Observability is great for cloud native applications, but it doesn't really work well if you have a Windows application. So those are the things I think you've got to watch out for, and use the tool or the set of tools that make sense for you. There are some vendors that offer a combination of these technologies. There are some vendors that buy a bunch of these technologies and offer a group of these technologies in a disparate way. There are some vendors that take a more unified approach and provide one solution, that has a single pane of glass view into all of these tools. So pick the one that makes sense for you.
Thanks, Karen. So when we have conversations with customers about the various different options that Kieran just talked about, and how to determine what sort of tool or tool chain makes sense for their Appsec, we often get into a conversation around the idea of Devsecops maturity. And part of that is because many of the customers that we talk to are trying to implement a DevSecOps sort of paradigm in their enterprise. So they're one of those companies that maybe started using, a scanning tool, statics analysis tool 10 to 15 years ago. Maybe they've got some container image scanning or security nowadays, but really what they're trying to do is they're trying to shift left. And I think in order to have that conversation, you need to have a good understanding of where your enterprise is in terms of its maturity level. So a lot of enterprises, unfortunately, and I won't even say enterprises, I'll say technology companies, right? And DFactor, I think to a certain degree was one of them at one point. That was before my time here, but they kind of are in ship first mode, right? They want their code to get into production as quickly as possible. They often have 1, 2, 3 customers that they're trying to keep happy. And so the idea is that you have little to no Appsec. You are trying to get directly into production as quickly as possible, and QA is primarily focused on feature capability. The next stage is reactive Appsec, and this is where a lot of early enterprises find themselves. Maybe they're just starting to get into software dev. They're moving away from monoliths, and they're starting their sort of digital transformation, if you will, into containers. They're doing the out-of-band security testing. Maybe they're doing it as part of a certification process. This is very common with things like HIPAA sort of certification process, or SOC or something like that, where you need to be certified. So you'll be doing a pen test, but a lot of what you're doing is reactive, right? You are shipping code, and then you're going back afterwards and maybe kind of cleaning up the mess. The next stage is that sort of crawling stage where you're starting to be a lot more proactive about your Appsec strategy, right? So you've moved away from just doing quarterly pen tests. You're not just scanning your code, but you are actively, or rather proactively, taking an effort to perform your Appsec during the pipeline, right? So this might be a code scan or a SaaS tool at the very beginning while your developers are in the build process. It might include running a DAS scan when the application's actually been deployed into staging. And then finally, maybe you're using an IAST in a combination of both staging and in prod. But the point being is that you are slowly starting to build this sort of self-sufficient process for Appsec. A lot of customers that we talk to are usually in stage 2 or stage 3. Where we're advocating that customers head and where we see the industry heading with a lot of the different evolutions to some of the Appsec platforms is this idea of continuous Appsec, right? And again, the idea of continuous Appsec is, I won't say just a unified platform, but an integrated and unified experience for Appsec. And the idea here is that you're not doing a bunch of disparate things one-off, right? You have a platform or a set of APIs that are all communicating to each other that are constantly performing Appsec sort of scans and analysis on your application, in development, in staging, and then onwards into production, right? A lot of these tools, especially in stage 2 and stage 3, and you look at some of these portfolio options that Kieran mentioned, what's happening is they've kind of built up their capabilities by acquiring different tools and different companies, and they kind of check all the boxes, right? And if you go all in with a vendor or you go all in with a platform or a portfolio rather, you might be able to, again, walk yourself through a very thorough sort of Appsec process. But the idea is to build this kind of positive feedback loop where you're constantly doing some sort of application security analysis on your app during every stage of the software development lifecycle. Now, the one thing I'll call out, and we do see this quite often, is there are a lot of customers who want to go directly from crawling to just running, right? They don't want to go through that growing pain. And so rather than go, get 5 or 6 different tools and try to integrate them all together and use something like Jenkins or CloudBees to make sure that they have a mature pipeline, right? They want to get rid of the old technical debt, the old legacy platforms, and then jump to something new, right? And I do think that if you look at like Sneak, for example, they have found a lot of traction in the Appsec space by offering a platform that's extremely mature, very easy to kind of log in, start using it, and immediately see value, right? They're a very good example of a modern platform that isn't Deepfactor, of course, that customers are kind of flocking to because it has a best-in-breed sort of mentality about the way that they approach Appsec. So just to kind of drill down into this a little bit, I wanted to give it a little bit more of a technical example of the various stages. So on the left-hand side, you've got your dev and your QA teams. Obviously, they're responsible for writing and testing the code. You've got your code/building process, kind of one and the same, right? Because at the end of the day, it's those artifacts that are going to be sent over to testing and staging where they'll be deployed and undergo QA. On the right-hand side, you've got your ops team, right? So they are different groups of people. Every customer conversation that we have, it's usually one or the other. It's not both. And it's something that we try to advocate for is bring both the dev and QA teams together with the ops team. Some tools are built for devs. Some tools are built for ops. So it's important to understand what exactly is the problem that you're solving. And that's something that Kieran is going to touch upon a little bit later in the presentation. So in stage 1 or 2, we talked about how most enterprises are really just doing the pen test. So they're trying to ship code as quickly as possible, get it into production, verify the functionality is there, and then go back after the fact and do a pen test. Because of that, they might be monitoring the application in production. They might be using a Datadog, for example, to, if they've got a SaaS platform, to just kind of ensure that, the app is running as expected and that no major flags are arising. But because they're not doing any scanning of the code or the build artifacts, because they're not doing any sort of AppSec in the test and staging environment, they're going to see problems in production. That's a guaranteed fact, right? And it's just a matter of how big is the fallout of one of those problems. Now, stage 3, which is where I think most of our customers are at and where a lot of our conversations tend to focus, is now you've got organizations that are being proactive about their AppSec. And more often than not, you'll have members of both dev and QA and ops kind of on the same page, right? They are in the very early stages of DevSecOps, where the AppSec team is working on both sides of that sort of fence, if you will, between dev and stage and testing and production to ensure that everybody's kind of on the same strategy when it comes to AppSec. Now, in this scenario, we are scanning the code. We are trying to proactively be involved and ensure that our code's being scanned before it gets built and sent over into testing and staging. Now, that's great because when you send this thing into production, right, what you're catching with your monitoring tool is going to be slightly less noisy. Hopefully, any fallout will be slightly less bad. Now, a lot of enterprises will get complacent at this point. They feel like they're doing their due diligence. As long as they're scanning their code and they're doing their analysis and they're following up with it on a quarterly basis, they feel like maybe they're safe. Now, you're not looking at the running application, and that really becomes where the issues start to arise. You might start to look at your vulnerability scans and realize, oh, you know what, I don't need to tackle these issues. They're not P1s in my book, right? Or I don't think that we're going to hit this. That's a corner case. Or, I think this only happens when we hit a certain scale number, et cetera, right? Those are the assumptions that a lot of enterprises and development and QA teams start to make, because the list of vulnerabilities and dependencies and packages that are being provided by a static scan tool are so large, right? And because they're not testing for Appsec in staging or in the testing environment, there are still issues that are going to arise when you get into production. Now, I like to put these numbers on the slide because I think it kind of indicates, why you can't just become complacent at this sort of stage 3, and why, you should be looking at something like an observability platform. So data breaches on average can be up to $3.8 million. Issues are often more expensive to fix in prod. In a previous life, I was actually a product manager, and I can't tell you the number of times that we had to roll back things because we didn't catch them in testing and staging, right? The sort of security posturing that we had wasn't mature enough to ensure that we didn't go to prod with issues. And I also think more importantly, you're forcing your development team to prioritize based on what might not be complete information, right? So do we need to fix this thing or not? Are we going to hit this bug, this issue, this vulnerability in production? And that's important because ultimately at the end of the day, you don't want to waste time, right? So if you can test the code in runtime, you can observe the application before you get into prod. You can refine the number of vulnerabilities you're going to see. You can catch system risks, et cetera. You can even catch things that you wouldn't otherwise catch, right? I think in recent news, supply chain hacks are a very important thing that we're just now realizing how easy they are to kind of slip through the cracks, and how quickly they can kind of blow up in our face. I think a good example was the one where they were, stealing Bitcoin wallets, and they were sending traffic, I think, back to Malaysia or Singapore, right? Where if you hit a certain condition with your NPM, your NPM file, it would start doing that automatically. So that's something that you would need to be able to test in runtime to catch. So that's stage 4. That's the idea of observability. And so, now you're scanning your code, not just statically in the sort of dev and build process, but you're actually scanning it proactively with tools like DAS, IS, and then hopefully eventually observability, where you're kind of analyzing that sort of runtime gap that exists. Kieran, I don't know if you wanted to add anything. I figured that may be a good opportunity for you to jump in if you had anything else to add.
No, that was great, Andrew. And one thing I'd like to kind of throw in is that you have I think as an Appsec team, you probably aren't starting from zero anyway. Like you have some baggage or some things from your existing tools, and that is totally fine. The question that I think you need to ask yourselves is, if this is an initiative that you're going through, is where I am sufficient for my apps? And do I need to add more tooling to identify the attack vectors or the compliance risks that I'm currently not identifying as part of the CI pipeline? Or is my engineering going through an architectural overhaul? Am I going through digital transformation? Am I going through cloud native? In which case, do I need to use this as an opportunity to kind of strip and start over and rethink my Appsec portfolio? So that's, I think the right tool completely depends on, or the right tools completely depends on, which, what type of application you have, what language is written in, your budget, and a whole bunch of other criteria. That's right.
Yeah, exactly. Yep. And I'm glad you mentioned CI/CD. So one of the things I touch upon too much in that last slide was just the idea of integrating your Appsec strategy into your CI pipeline. So some tools, like Kieran mentioned, are better than others for that sort of integration, right? No one necessarily is putting a pen test into their CI pipeline necessarily. DAS tends to be a little bit slower than something like a SAS or an SEA. IS is, it requires potentially quote unquote code changes, right? But it's going to give you very accurate results. So the idea here is, as you're writing your code and you're merging your code, you're kind of hitting all those different gates that you need to hit to ensure that you have a fully validated and secure application before you get into release. And the idea is that once you get into release, the reason it's a dotted line is because maybe release doesn't happen. Maybe you get to the DAS or the IS scan, or you start to observe your application and runtime at staging, and you realize, I'm not going to release this thing. We need to go back to the first step, the write code step, and actually, fix these bugs. I think that's an important element of any tool that you evaluate is, can this be fully instrumented inside of my CI pipeline? Because the eventual goal, the idea of continuous AppSec is to, at least in my mind, is zero touch. Can I create this positive feedback loop where I've got all these different tools and platforms, whether they're integrated and unified or not, that are positively improving the results and the security of the application before I get into prod, without necessarily manual intervention, right? The idea would be I need to do a pen test literally only so I can get a compliance check, not necessarily because I'm not sure if my application is secure or not. So Kieran, I think I'm going to hand it back over to you on this slide.
Cool. So, I mean, there's one of the questions that we get asked, not as Defactor, but as thought leaders in the space, is there's so many tools out there. How do I classify them, and what tool makes sense for my organization? This slide is a great way to kind of classify them, and let me walk you through the slide a little bit. There are two groups of people or personas that need visibility. One is, I'm going to bucket devs and Appsec teams in one bucket. These are the groups of people that care about securing the application, creating a secure application to begin with. So the tools that they're interested in is Appsec testing tools. That is the first gray line that you're seeing on the top of this diagram. The bottom gray line that you're seeing on the bottom right is the second persona, which is, I don't care about securing the application per se, or that's not in my purview, because I am an operations person, SecOps or related. And my job or my primary interest is to secure the infrastructure. So what I need is a cloud workload protection product that makes sure that my cloud infrastructure is secured right, my host machines are secured right, my Kubernetes cluster configuration is done right, those sorts of things. So depending on, this presentation is mostly catered to the first bar on the top, not for the operators, because there are tools for the operators like, Qualys Tenable that do, vulnerability scanning, or, the Prisma Clouds, or Aquas and, Twistlocks of the world that, are sidecars that identify risks in your, infrastructure, so on and so forth. This presentation was primarily focused on the top bar, where we are talking about the best ways to create and ship a secure application. So let's go through that, double click on that a little bit. So we talked about the various tools. So there's two parts to that bar. One is during the dev stage, or during the coding stage, or the build stage. You're looking at your static code, and you have static code scanners like SAST. Static code scanners are SAST. And then you're also looking at identifying vulnerabilities in your dependencies. So you do software composition analysis or container image scanning. And from a supply chain perspective, these days it's becoming pretty an important topic. So, software bill of materials and getting a handle on that is very important as well. So you have some of these SCA tools that offer some, bill of materials capabilities as well. And then that's one side of the coin. The other side of the coin is observing a running application. So that's where you have tools like DAST, which pokes the app from the outside and scans the app from the outside. IAST, which was the first generation tooling that looked at the app from the inside, but it required custom agents, language specific, all of that. Observability looks at the app from the inside, more designed for cloud native workloads, language agnostic, no code changes, and whatnot. So these are the tools, and we've tried to group vendors into some of these buckets. We may have missed some vendors, or possibly slightly miscategorized some of the vendors. If that's the case, apologies, no harm intended. It was purely done to present the best possible information in our heads to you guys. So on the left here, where you see SonarQube and WhiteSource, these are tools that are created by vendors that have point products. These vendors specialize in SonarQube, for example, has code scanning. WhiteSource, for example, has dependency scanning or software composition analysis. These are point tools. Then you have on the right side where you have tools like StackHawk or New Religion. These are point DAS tools. They do dynamic application security testing. That's it. There are a group of large companies, Checkmarx, Synopsys, Veracode, HCL, White Hat Security, all of that. What they've done is over the years, as new technologies came along, and new companies came along, they've acquired some of these companies, or in some cases built organically, and created a portfolio of tools. So these are companies that have a SAST, they have a software composition analysis, they have a DAST, an IAST, so on and so forth, but these are all separate tools. It's offered by the same company, but these are separate tools. Now, there's some of the companies that are up and coming now, such as Defactor or Sneak or Contrast Security. We're taking a more unified approach to Appsec. Like our approach is, these are not 5 different tools. You drop this in to your environment or your CI/CD pipeline in one fashion. It gives you one integrated experience across your software composition analysis, across your container scanning, your runtime visibility, so on and so forth. And again, there's slight differences between each of these vendors. For example, Sneak is more specialized in the static side of the world, so they have more software composition analysis and container scanning. They have very little runtime visibility. Defactor is completely, is focused on runtime observability. It doesn't have a static code scanner. So, and Contrast Security, for example, gives you, it doesn't have a software composition analysis tool, but it has a SAST now, and it has an IAST from the past. So depending on what makes sense for you, for your application, some of these tools might be right. Maybe you're happy with a pointed SAST or a CA tool. Maybe you're happy with a pointed DAS tool. Maybe you're okay with a vendor because your goal is to consolidate vendors, in which case you want to buy 5 different tools from the same vendor. That's fine. Or maybe you want to take an integrated approach and check out one of the newer tools because you're going through that cloud digital transformation journey. Really a matter of what makes sense for your enterprise and your organization. So hopefully this slide does justice to the infrastructure out there, and hopefully it gives you a one-slide view of how to think about application security testing tools versus cloud workload protection tools, and then which in the application security testing bucket, how do you subclassify each of the vendors out there?
Yeah, and just so you know, we're not crazy. I believe this is how Gartner also defines them as well. So just if you want further validation that we're not trying to paint some picture that we only believe, it's something the developer versus operations bifurcation is definitely something that is prevalent at the analyst level as well. So great,
awesome. So as you're thinking about your priorities and you're trying to figure out what is your DevSecOps strategy, then here's a quick kind of simple decision tree that we would kind of want to guide you towards. The first thing is that there's an alignment between your engineering leadership and your security Appsec folks around the fact that you want to provide visibility into your application security posture throughout the course of development, and where the setup of the tooling is seamless to your dev teams, can easily be integrated with the CI pipeline. Appsec blesses it, DevOps puts it in the CI pipeline. But the consumption of the tooling, where the insights are actually consumed by developers, are dev friendly, and they can be provided with every release or however often you want to get that visibility. Once that understanding between these teams is there, then I would start with the business driver first. What is the business driver that is resulting in you evaluating your DevSecOps initiative or wanting to do a DevSecOps initiative? Is it digital transformation? Meaning, are you microservicizing or containerizing your application, going from legacy to monolithic to cloud native? And you're using that as a nice transition point to add security tooling in there? Or is it more the fact that you have an existing set of tooling, but you want to integrate with the CI pipeline? Or is it driven by compliance? You want, Biden's executive order just came out, so you want a software bill of materials visibility, or you want PCI or other compliance to meet those standards, and you want to find, you want to add that during your CI pipeline. Understanding that and making sure that your rest of the goals are aligned towards that business driver makes a lot of sense. The second one is, who is using the tool? Is it devs and QA that want to consume the insights, or do you want the Appsec teams to still be involved in the day-to-day triages, or do you want the Appsec teams to set the guardrails and make sure that the devs kind of take ownership of triaging these issues? And as long as there's a P1, do you want to gate the bills? I mean, those are the types of things that you probably want to understand as well. Once you've done that, the next step is to understand your technology requirements, which is what types of workloads and apps do you want? And are you building a .NET application, which has been there for a while, or are you building a Kubernetes application, running in Python or Golang or something like that? What is it that your application stack looks like? Is it a cloud workload, or is it a mobile or desktop application? Depending on what it is, you need to figure out which vendor or which kind of tooling makes sense. And then you decide, okay, what's your budget and timeline? Depending on my budget, do I have the budgets to buy, to stitch together a bunch of open source tools? Is that what I want to do? Or do I want to buy a commercial product? If you decide that you want to buy a commercial product, then you need to understand, is it sufficient for you to just to SAST or just scan your build images? Or do you want to get visibility into, OWASP top 10 type issue, using your DAST or, other runtime, IAST or observability, runtime kind of insights? Or do you want to buy tools from a vendor, different tools that are offered by the same vendor? Or do you want to buy an integrated experience that kind of gives you, more bang for buck with respect to budget? I think, but it may not be a specialized tool for for a particular module. So I think lots of those decisions need to come in. So our recommendation is understand your business driver, understand your personas and who's going to be using the tool, align on a process, then understand the technology requirements, then your budget, and figure out the vendor assessment. And it's not just a one-time project, as you guys all know. There's the one-time aspect of setting it up, but then there's the constant aspect of making sure that the machine is well oiled with respect to day-to-day bug triaging, et cetera. So making sure that there's a proper process in place for that.
I would almost advocate that this is a circle as well, because it's, you're not just going to decide, what is my business driver and then move on to the next question. Your budget and timeline and the sort of resources that you have on your staff might determine both your business driver as well as your technology requirements. Do you need something that is provided by a vendor that maybe has a nice GUI and is easy to understand? Or could you, go use OWASP Nettacker and you have the expertise on site to be able to do something like that? I think this is a common theme in the sort of open source versus vendor paradigm, where it's, what are you in the business of doing this yourself, or do you need someone to kind of help you on that sort of transformation journey that you're about to go on if you're moving from a monolith to a Kubernetes? So anyway, the point being that I do think that this is really a decision circle, not necessarily a decision tree, where you've got to be conscious of all your different capabilities, price, budget, technology, et cetera, to make the right decision for your efforts. So that was our last slide. If there's any questions at this point, we'd be happy to answer them. Again, slight plug, if you want to learn more about Deepfactor, or you would like to, have a follow-up conversation with myself or Kieran, we're always available. This is our website. There's a contact form there that you can go fill out. But we really enjoy doing these meetups because it's an opportunity to really just be a part of the community. My favorite part about being at KubeCon last week is, the free drinks, but also the sort of networking that you get to have with the community. And so meetups are probably the closest thing that we've had over the last 2 years that continue to sort of emulate that conversation. So thank you for letting us come on and talk about, our opinions and what we think about Appsec evolution.
Yeah, thank you, Andrew. And to add to what Andrew just said, whether you want to learn about Deepfactor or not, we'd love for this community, to stay in touch with us. So please hit us up on LinkedIn. You have both of our contact information. We're happy to just geek out on these topics and network. It doesn't have to be Deepfactor related.
Yeah, we didn't even bring the smartest people in the company, so we have other people that can also help dive even deeper on some of this stuff, which is great.
Yeah. Thank you, Wendy, for the opportunity.
Oh, of course. Does anybody have any questions? I don't know if you guys want to give it a couple minutes or if we're good.
Yeah, give it a minute.
Okay.
Yeah.
Don't forget, if you want to ask anything, it's on the Q&A since no one really has, no one has audio abilities to speak, but just post it and don't be shy.
Okay, I guess we can go quits then.
Yeah. Well, thank you again. Really appreciate the opportunity.
Thank you.
Yeah,
Ryan.
thank you both. And that was a great talk. All right, everyone, with that, thanks everyone for showing up and being a part of this. Have a wonderful weekend.
Thank you.
Bye. Bye.
Bye.